Hello and welcome to the presentation on section 8.4, metallic bonds and properties of metals. Nice quick section here, which I like. I'll start off with a cartoon. Right in the middle of the produce aisle, Frosty gets caught picking his nose as we hear the laughter. Metallic bonds. We just covered ionic bonds in the first three sections. Now we're just going to have one section on metallic bonds. The second type of bond we're going to be covering in this course. Metallic bonds. It's the electron C model, where the outer level electrons are not held by any one atom. So they're going to be basically free to roam. They're free to move anywhere in the metal, and they are called delocalized electrons. You can see a picture of them kind of sitting there. The yellow are the positive cations, or the positive nucleus of the metal. The blue are the electrons, and again, they're not held by any one nucleus. They're free to move all over the place. So what a metallic bond is the attraction of the metallic cation for the delocalized electrons. So again, these electrons, they're free to move all over the place. They can move all over. They can weave in and out, go in between between them, and move around. This creates some pretty unique properties with metals. Gives them a lot of the properties that they have. Number one, malleability. It's able to be flattened out into sheets. Again, these electrons just can move wherever they want, so they get pushed off to the side. You take a hammer to a hunk of gold, for example, flatten right out. Ductility. You can pull it into the form of a wire. You can do that because of these delocalized electrons. They're not rigidly around a particular nucleus, around the positive part of the metal, so they're free to move. So you're able to pull and stretch the metals. Melting points do vary greatly, but typically they are going to be moderately high. And the boiling points are also going to be high because of this. Alloys. We've talked about alloys a little bit before. It is a mixture of elements that have metallic properties. Brass would be your copper and zinc, combination of those two. We've seen that a couple of times already. These alloys can form in two ways, where the two metals can mix together. One way is that you have atoms of similar size. So let's say, for example, you have some of these atoms lined up here, and then some of these atoms, and they're lined up here. So they're of the same size. They can fit in and amongst each other. Might not be the best drawing. Probably be similar to this, actually. Should be a red one there. Another red one here, green one here, green one there, and so forth. So then they're going to be similar size. They can pack really well together. So that's where they are of similar size. You can also have them where their size varies greatly. So what you can have is some bigger ones. And then you can have some smaller ones that go in here. So you have the bigger ones and the smaller ones. The smaller ones take up this little spaces that the larger ones create. So there are two types of ways to make alloys. Similar sizes and ones that differ greatly in size. Some big and one big and one small. And if you have something in between there, typically they're not going to mix very well to create an alloy. And that is all we have. Nice short and sweet presentation.